Hello and welcome to part 2 of 5.3. This part is terminating or repeating decimal numbers. Problem set 3. Show that the following rational numbers can be expressed as terminating decimal numbers. With number A, have 3 over 5. To express the rational numbers in decimal form, divide the numerator by the denominator. If you use a calculator or use long division, you will obtain the following results. That's what the book says. So if we take the numerator divided by the denominator, or if you say this in your calculator, 3 divided by 5 in this case, you're going to yield something like 0.6. Or what that means, you can, or using long division, if you pull the denominator to be out in front of the long division and have 3 inside, as you can see, 5 will not go into 3, so if you put your decimal and add a 0, remember your decimal is going to go up here, meaning that it did not go in first. And how many times will 5, as you can see, go into 30? It will go in 6. So that is how you get your answer using long division or using your calculator. For B, if you pull 20 out and have 13, and of course you know the answer is going to be a negative because it's positive or negative divided by positive. That's how you would do it using long division. And as you can see, 20 will not go into 30, so you have to pull your decimal out, make it 130, and if you carry it all the way out, you're going to get 0.65, which in this case will be a negative 0.65. Or just type in your calculator, negative 13 divided by 20. Okay, and finally for part C, you can either do the 16 divided by 23, and as you'll see here, instead of getting a 0 first, you're going to get a 1. And if you carry it all the way out using long division, you're going to get 1.4375. Or if you just type in your calculator 23 divided by 16, you're going to get the same thing, 1.4375. For number 2, show that the following rational expressions can be expressed as repeating decimal numbers. So if you use a calculator or use long division, you can acquire the same answers, saying that 3 divided by 2, or use the calculator approach of 2 divided by 3, you're going to yield something that looks like 0.6. And this little bar on top tells you that 6 will keep repeating forever. Using the same approach, if you use long division, you can say 99 divided by 14, or punch in your calculator of 14 division symbol 99, and either way you're going to yield a 0.14, and it's over both 1 and 4, meaning that 14 will repeat. And finally, we have one more example for this portion. We have 15 divided by 36. You can say 36 using long division divided by 15, or you can just punch in your calculator 15 division symbol 36. And either way, you're going to yield that you get 1.138 with that 8 repeating. Okay, now we're going to convert decimal numbers to fractions. Convert the following terminating decimals to a quotient of integers and reduce the quotient as needed. Okay, so what you want to do is think about 0.7. But that's really saying this is in the tens place. That means it's only one place past the decimal. So you can think of that in the terms of 7 over 10. If you were to punch 7 divided by 10 in your calculator, you would get 0.7. So this is how you would just think about moving the decimal point to the other side, just by multiplying by 10 or dividing by 10 to keep it where it is. Okay, thinking of 35. 35 is two places after the decimal. So if we wanted to move it to the other side, we'd have to multiply it by 100. Well, to keep that 35 where it is, you want to divide it by 100. Think of it as how many places past the decimal the number is located is how many zeros after the one you want to divide by. There were two places after, so you want to use two zeros. With C you have 16, and if you notice there's a zero there, so there are actually three places. So you want to have one and then three zeros to divide by. And keep in mind that you can reduce these if you would like. This 35 over 100, you can think of 35 as the product of 7 and 5, and 100 as the product of 20 and 5. With these 5 canceling out, leaving you 7 over 20. And with 16 over 1,000, you can think of that as 16 being multiplied by 8 times 2, and 1,000 being 8 times 125. Those 8's will cancel out, leaving you with just the fraction 2 over 125. And there is one more for us to look at. I almost skipped it. Okay, so you have 3.41. Okay, so what you want to do is break it apart as 3, which comes over here, and this 41, this 0.41, which as we use our rules before, we can think of that as 41 over 100. And for this, we want to say that that is equal to two pieces being added together, where the denominators need to be 100. Well, we have this one right set up as 41 over 100, but now we need to make this 3 over 100 have the denominator of 100. So what we do is to take the denominator we wish to have and multiply it by what we have already. So we have 100 times 3, that's 300, so that's going to be our new numerator. So now our fraction is going to be 341, because we just added 341 over 100, keeping our same denominator. And that will not reduce. Okay, so now if we want to convert the repeating decimal to a fraction, so we have 0.33 going on forever. What we need to do is look at this as 3.31, or 3.3 repeating. And how did we get this 3 to move over? We had to multiply it by 10. So let's say, since we multiplied by 10 to get 1 3 moved over here to the other side, and let's place an n right there as a variable. So all we did was show that it took to multiply by 10 to move one of these 3's to the 1's place of this decimal. Now the goal is to subtract by just what n is, which is 0.3 repeating. So what we essentially said that n was equal to 0.3 repeating. And to multiply by 10, this is what we got for the first part, and then we're just leaving the n as it is. Now if we subtract the 2, we're left with 9n on this side, because there's that one coefficient in front of n, is equal to, as you'll suspect, this repeating decimal will cancel out because they're being subtracted, leaving you with just 3. Now to solve for n, you want to divide by 9 on both sides, leaving you with the fraction 9 over 3, which will just reduce to 1 over 3. So that is the actual fraction that it was looking for.